Hello, everyone. Hello, and welcome to Best Practices for Amazon S3. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'll be joined later on stage by Katie Lampkin, who is a software engineer at Human Longevity. This is a company that's using data to deliver health intelligence. And you'll hear much more about their business and how they're using S3 later on. So let's jump right in. Today we'll start with an overview of Amazon S3. Then we'll talk about how you can manage and secure your storage in S3. Talk about how you can add additional levels of data protection to retain certain subsets of data that are more important to you. We'll talk about achieving high levels of performance on S3, and then we'll hear from HLI. Today's talk will focus on Amazon S3 and Amazon Glacier. These are our object storage services in AWS. We also have block and file offerings, which have other discussions this week. They have their own booth if you want to ask questions about them. And then we also have data transfer tools, both to enable you to do large-scale migrations and then also manage the ongoing uploads and downloads to the cloud. We'll talk a bit about transfer acceleration in particular later on. So when customers look at S3, they're choosing it for these reasons. It's designed to be a durable object store, designed for 11 nines of durability. You can achieve 4 nines of availability in S3 standard. You can also scale to petabytes or exabytes using Amazon S3. When we look at security and compliance, you have 3 different ways to encrypt your objects in S3. So you could use server-side managed by a customer where you provide the key, or you can use key management service, Amazon AWS KMS, to encrypt your objects. We also have compliance storage offerings. You can achieve FedRAMP, HIPAA, or PCI compliance using Amazon S3 storage. On query in place, we have Amazon Athena and Amazon Redshift Spectrum, both of which allow you to analyze data using SQL across S3 and also taking in data from your data warehouse as well with Redshift Spectrum without requiring you to extract or load that data into any other service. We have flexible management tools. We'll talk today about object tags, storage class analysis, and S3 inventory. So these are management tools in addition to cross-region replication that you can use to get better visibility on your storage, to automate, monitor, set alarms. For cross-region replication, you can replicate your data across AWS regions. So you have a lot of flexibility there on the management front. And then our ecosystem consists of tens of thousands of consulting, system integrator, and ISV partners. You also are highly integrated with the rest of AWS services, so you can use your storage in Amazon S3 and use it with many other services, some of which we'll be launching this week. You have a choice of storage classes when you choose Amazon S3. So this ranges from S3 Standard to S3 Standard Infrequent Access to Amazon Glacier. These all have different cost profiles. So you see that Amazon Standard is from 2.1 cents per gigabyte per month all the way to Glacier at 0.4 cents per gigabyte per month. What you're trading off when you choose between these storage classes and the different characteristics you're going to see is about data retrieval times and also data retrieval fees. So with S3 Standard, there's no retrieval fee, and you're able to retrieve your data within milliseconds. It's a high-performance storage class. With Amazon S3 Standard Infrequent Access, you have basically the same performance traits as you see in S3 Standard, but now you're paying a data retrieval fee of 1 cent per gig per month. So a simple thumb rule, and we'll go into this in more detail later, is let's say you retrieve all your data 1 time per month. So you have about an 100% retrieval rate on whatever you're storing in Amazon S3. You're about indifferent between S3 Standard and S3 Standard Infrequent Access, just based on the pricing. So that's really the decision point at which you're neutral between the two. If you're retrieving any less than 100% of your data, you should really consider S3 Infrequent Access for a subset or a majority of your data. So that's something we'll talk about, some of the tools that would help you with that later on. As your data gets even colder and moves more toward an archive tier, where yes, I might need the data back, but I can store it in Amazon Glacier, and I have the option to retrieve it within minutes if I need to, or I have the option to retrieve it in bulk. So if I can retrieve it maybe 5 to 12 hours later, I could use bulk retrieval from Amazon Glacier, get a whole lot of data back in that period of time at a very low cost. So those retrieval tiers give you an option of getting your data back very quick, within minutes, or within hours, and there's a different fee associated with the retrieval there. So you save a lot when you move your data to Amazon Glacier, especially if you're not retrieving it very frequently. The durability and availability, I want to go into a little bit more detail here. When you store your data in Amazon S3, it's stored across 3 different availability zones. So these are geographically separate locations They have different networking connecting them, so they have independent networking traffic between the two, between the three of them. And you also have independent power sources. So you have redundancy built in between those different availability zones, ensuring that we can lose an availability zone and still be able to deliver your data to you. So your data is still durably stored and it's available and we can deliver it back to you if one of those AZs goes down. And as I said, designed for 11 nines of durability, and then you see the availability numbers there for S3 standard and S3 standard infrequent access. First, we'll kick off and we'll talk about storage management as a section. Talk about object tags, lifecycle management, storage class analysis, and then talk about some of the new enhancements to S3 inventory that some of you might already be familiar with, but really adds a lot of new capabilities to S3 inventory. So we'll go into those in detail at the end. This first slide shows you the storage management portfolio. And this is really a reflection of how we continue to improve S3 and how we listen to customer feedback and make it easier to automate, monitor, and alarm on your storage. So we have a few features that we'll go into in more detail now, but you have a lot of flexibility here where you no longer have to worry about those management tasks because you configure alarms and take action directly off of those using CloudWatch events. So you can revert changes that are made to your storage using some of these tools. And then things like storage class analysis give you the insights you need to know what data should I move to infrequent access, take advantage of the savings, and not worry about the retrieval fees. So there's a lot of powerful features here that we'll go into more detail now. Starting with object tags, these are key value pairs. So this is custom metadata that you add to any of your S3 objects. You can add up to 10 tags per object, and you can change and edit these at any point in time. And you'll see how important that is with some of the examples we go through. I'll talk a bit about alert logic in part of this slide, but then when Katie talks about human longevity, you'll see how it's great that you can change these tags over time and control access to your storage based on just these tags. You don't have to do anything with the data. You don't have to copy the data. You don't have to rewrite the data. It's all just a manipulation of a tag on the data that's going to control access and allow you to do a lot with it. So number one thing is access control, as I just mentioned, where you can set bucket policies or IAM user policies based on what tagged objects should this user have access to. So I only want this user to read particular objects with a tag attached to them, and we'll walk through some code examples on that. The next one is lifecycle policies. So many of you, I'm sure, are familiar with lifecycle. You can write those policies at a bucket or prefix level, depending on how granular you want to control your lifecycle policies. But now you can do that with object tags as well. So you can apply tags particularly to a subset of objects, knowing that that lifecycle action, whether to transition or expire storage, is only going to take effect on those tagged objects. Once again, you can change those at any point in time to apply to a different set of objects, or you can delete those tags, and then that lifecycle policy won't take action on those objects. What Alert Logic is doing, and some of you might have attended their session earlier, is they have a number of end customers stored in a single S3 bucket. So they'll have 950 customers worth of data in one bucket. They use tags to keep track of which customer's data is a particular object and when was that data originally created. So for them, the creation date in S3 when it's originally uploaded does not match necessarily with when that object was originally created and when that data maps back to. So they also track the date, the month in particular that that data was created as part of an object tag. Then they write custom lifecycle policies each month saying, OK, this customer's data should now transition to standard and frequent access because 3 months has elapsed. So that's the way that they use tags to control lifecycle policies. Now we'll talk a bit more about lifecycle policies. So these are rules that allow you to automatically transition or expire your storage. Transitions refers to moving S3 standard storage to S3 infrequent access storage, or moving that data to Amazon Glacier. So once again, you're taking advantage of the savings because those storage classes are lower cost, and you are doing that over time as your data cools off and you retrieve it less frequently. And we're taking that action based on object age. So potentially you'd write a policy saying, and we'll talk about an example right now. An example would be, after 30 days, move the data to standard and frequent access. Maybe I have a lot of processes that kick off after a day, maybe in the first week. So I see a lot of retrievals within that short period of time, and then over time, you see that retrieval really cools off, and after a month, I'm almost never touching that data. I still want to get it within milliseconds. So maybe a month later, we have applications to kick off and need this data, and it's going to need a small subset of the data. Might be a great fit to move it to standard and frequent access. I can still get it in milliseconds, so it's available if I need it. After 90 days, though, so after about 3 months has elapsed, now I'm not seeing nearly any users needing this data. Maybe this is billing data. Maybe this is compliance storage. This is something I might need to retain for a long period of time, but it's not important that I get it within milliseconds. If I need it, I know I can get it in a couple minutes, and that's good for me. And if I need a large subset of it, you could use bulk or standard retrieval from Amazon Glacier as well. So this is a way that I put in place on this bucket, move it to infrequent access after 30, move it to Amazon Glacier after 90, and now it's hands-off. Those rules are now taking action. As new objects are uploaded, they'll follow these rules, and I'll just take advantage of the savings over time. So as time goes on, storage will move to these lower tiers, and you'll see your storage bill adjust accordingly. But we got feedback from customers. So the feedback was really around, how do I know what the right number is? How do I know if 30 days is the right number to move to infrequent access? And how do I know 90 days is the right number for Amazon Glacier? What storage class analysis does, when you configure it at the bucket, prefix, or tag level, saying monitor this subset of my storage, it's monitoring the data retrieval in that storage. So how much of that storage was retrieved over a period of time, and when do we recommend moving that storage to infrequent access specifically? So this is taking into account the cost difference between standard and standard infrequent access and looking at the data retrieval fee. So that 1 cent per gig per month, as long as you're retrieving about 100% of the data or less, you'll see savings in infrequent access. This tool is showing you how that data retrieval, how that frequency of data retrieval changes over time, and then giving you a number to go back and write in your lifecycle policies. So I want to show you a visual of what that looks like. This is what you're going to see in the S3 console when you set up this feature. After 30 days of monitoring your storage, you're going to get a view like this, where it's showing you the different object tiers. So there's a less than 30 days and a 30 to 45 days. And one of the things that draws my eye initially is these labels. So at first, you see frequently accessed. OK, that's interesting. Now I want to drill in. If you look at that less than 30 days, so this is in the top left, it's classified as frequently accessed because as you see in purple there, I'm retrieving about 300 terabytes of storage, but I only have 200 terabytes stored. So it's about 150% retrieval versus the storage. If 100% is where I'm indifferent between the two storage classes, standard or standard infrequent access, we're seeing a higher amount of retrievals here. So as I walk my eyes over, the first tier where I see that it's infrequently accessed is after 90 days for this particular bucket. So now we're labeling it as infrequently accessed storage and recommending the move to infrequent access. So you're seeing now retrievals in the range of 10% or less for these tiers. So after my data is about 3 months old, I'm retrieving very little of it. This would be a great fit for infrequent access. I'm going to save money if I move to that storage class. So I'd go back to the previous slide. I'd look at the lifecycle policy I'd written, or maybe I haven't created one yet, and say, write a lifecycle policy, transition all storage to infrequent access after 90 days. That's a way I'd take this information, plug it right into the lifecycle policy, and now I have a data-driven way to write my lifecycle policy. Mentioned S3 inventory earlier. A lot of changes to this feature, a lot of new updates. At a basic level, it's a way to list out all the objects in an S3 bucket or an S3 prefix. So we have customers that have grown to an incredible scale in S3, millions and billions of objects. And it's hard to list those using a list API call where you're listing those objects 1,000 at a time. This requires a separate process to list all those objects and then create a list you can really work with to run queries or something else that you want to kick off with your storage. S3 inventory is a feature you configure, say on a daily or a weekly basis, I want an inventory list delivered to my bucket. And this is a list of all your S3 objects and associated metadata, things like what storage class that object is stored in, how many bytes that individual object is, or replication status. So if you have something like cross-region replication configured, it's going to show you whether a replication has succeeded, whether something's a replica copy for a destination bucket. It's an easy way to view how your storage is and do advanced analytics based on that to see how your storage is by the different tiers, or to do another process based on maybe what the object key name is. If that's meaningful to you, this is a great way to look at the object key names and see what you can learn from that. Recently, early in November, we launched a number of enhancements to this feature, so I'll touch on them now. One of the big ones, and customers like Capital One were asking for this, is I want to see the encryption status of all the objects in my bucket. So I have compliance requirements. I have requirements saying I need to encrypt all my objects. And maybe it's tough to enforce that on all your users. So you're not sure if all your objects have been encrypted, and you want an easy way to view all your objects and see that. Now you have encryption status as part of the S3 inventory report. So you see not only whether it's encrypted, but whether it's server-side or KMS encrypted using the key management service. You can also now encrypt your S3 inventory file. So once again, if you have compliance requirements around your storage, this is an extra file that's being written. Now I can specify whether it should be server-side or KMS encrypted when it's delivered to my bucket. We also made the inventory report no longer just available in CSV format, but now available in ORC, which is a columnar data format. That makes it much higher performance when you run queries on your S3 inventory file. And as I mentioned, when you get to millions and billions of objects, this can be a rather large file. Using a columnar format and using Hive-based tools will allow you to get faster query results and get to the information you want faster. We also launched the ability to now it's more compatible and easier to integrate with Amazon Athena and Redshift Spectrum. So it allows you to get quicker up and running. You'll see these examples in the docs, but now you can point your inventory file, you can point Athena to it and say, I want to run a query based on what objects are encrypted and what types. Show me all my object keys, which ones are encrypted using server-side KMS or which ones are unencrypted. You could get started with that within seconds, get results back in a matter of seconds or minutes, depending on how big your file is. So this is a great way to take the new enhancements to this and get to easy insights and easy visibility on what's encrypted, what's not, what you have to go back and encrypt. Which segues to the discussion of security, where we'll talk more about encryption, access controls, CloudTrail data events, and then Amazon Macy, which is a new service that launched in August. A lot of powerful capabilities there I want to make sure you're all aware of. So when you want to encrypt your data in Amazon S3, you have options. You can use server-side encryption, where we have 3 different options, or client-side encryption. Client-side encryption would be encrypting the object before you even upload it to S3. So you upload encrypted data to us, we'll store it as an object, we'll deliver it back to you, still in its encrypted form. You can manage that all on the client side. If you want to take advantage of some of the services we have on the server side, though, it takes the work off of you and lets Amazon S3 manage it for you. The first one and the most basic is server-side encryption S3. So we manage the data and master keys. You just specify that you want your objects encrypted when they're uploaded. This is encryption at rest. So keep in mind that if an authorized request comes in to read your object, we're going to decrypt that object and then deliver that object out to whatever customer or whatever account requested it. So that's something to keep in mind here. It is encryption at rest. Server-side encryption customer refers to you providing a customer key. So with your request both to put the object in S3 and then also to get it back, you specify the encryption key. And we use your key that you provide to encrypt or decrypt the object, depending on whether it's a put or a get. This is something where you manage the encryption keys at that point, and we just use them for the encryption, decryption, and throw it away at that point. So it's not stored in S3. The other one you have is server-side encryption with the key management service. So this is AWS KMS. And using KMS, there's a data key used in S3 to encrypt your data, and then there's a master key retained in the KMS service. Different from SSE S3, which is the first one I laid out, where it's encryption at rest, you have an additional level of protection when you choose KMS to encrypt your data. Because customers not only need the approval and authorization to read that object from S3, but they also need the permissions and the proper permissions from the KMS service to actually get access to the master key to decrypt that object. So if you have customers reading data who aren't authorized by the KMS service, they're just going to be getting absolute gibberish from S3. So that's a way to keep your data at an extra level of security and make sure it's encrypted only to the authorized users who have authorization both in S3 and KMS to read your data. So this is an additional level of data protection, and we have a few other features that interact with KMS later on. So that's a way to add an additional level of protection when you're choosing to encrypt your objects and then use KMS. One of the other new features launched in November is encryption by default, which is a feature at the bucket level, allowing you to specify for a given S3 bucket whether you want all objects encrypted with server-side encryption or encryption using the KMS service. So for customers that want to enforce encryption on all objects uploaded to a bucket, this is a great way to do that. It makes it easy to satisfy compliance requirements, and it ensures that all those objects will be encrypted. If you upload an object and you're going to put an object to this bucket that already has a specified encryption type, so let's say I set default encryption as you see up on the screen, where it's server-side encryption by default. If I do a put with KMS encryption, we'll continue to store that object with KMS encryption. So we'll respect whatever encryption's in the request, and if there's no encryption specified, then we pick up the default encryption status here. So you're still able to specify for potentially higher requirements what encryption you want, and then we'll just ensure that default encryption applies to any request where there isn't an encryption specified. And this is a way to, on an ongoing basis, ensure everything's encrypted in your bucket And in conjunction with this, you could then use S3 inventory to see what objects are not encrypted and still need to be encrypted. Great way to put those features together and ensure everything you need to be encrypted is encrypted. Next, I'll walk through a bit of a progression just talking about security and how it works in S3. So this is a great way to think about there are access control lists, both at the object and bucket level, bucket policies, and then IAM user permissions that you can manage. So these are a few different options, and we want to give you those options, but I want to talk through briefly now some of the choices you might make on and how a request is actually authorized, to give you some information to then do more research and find out exactly what's right for your data and what's right for what part of your data. One disclaimer I'll add to this one is for the bucket access control list, so for the bucket ACLs, the only recommended reason we have to use that would be for an S3 bucket logging group. So for log delivery from Amazon S3, for example, where you're delivering logs to a bucket, that's a great way to give permission to the logging group to actually write those logs. But outside of that, we really recommend bucket policies at the bucket level, and then object ACLs as necessary at the object level. So bucket ACLs really won't be used that frequently unless you're giving permission to the logging group. So I'll start with just a simple S3 bucket. And then I'll start uploading some objects just so we have a reference point for later on. And then here you see the folder icon appear. For those familiar with the S3 console, when you add a prefix to your object key name, so this is just a slash and then adding additional information to an object key name when you want to organize your data, it looks like a folder in the S3 console, so an easy way to visualize it, but it really is just an additional part of your object key name. That's just the way we're rendering it visually. So now we have a bucket, we have some objects in it, we also have a prefix where we have additional objects, so music files, documents, and we'll talk about how we authorize a request. So at the bucket level, it's fairly simple. There's really just two layers we're looking at. So IAM roles, which you can set up on your account or other users might have set up on their accounts, have permission for what services they could access. If the IAM user who's trying to make a request against your bucket doesn't have permission to access S3, doesn't have permission to access your account in S3 depending on how it's set up, then that request is declined right away. If an actual account is making the request, though, and not an IAM user, we're going to look ahead then to the bucket context. So this is evaluating bucket policies and bucket access control lists to make the decision. So there's a particular type of request. It might be changing a configuration on the bucket. Is that allowed in both the bucket policy we'll look at or the bucket access control list? At the object level, you add an additional layer to that. So once again, does this IAM user have permission to access S3 and this type of request? The bucket context, which is looking at, in this case, whether there's an explicit deny. So if there's a statement in a bucket policy saying no one can get data from this bucket, then that request to get an object from this bucket would be declined at that level. But if there's not an explicit deny, we're going to then look at an object access control list to see whether permission is granted. So you'll see another feature in just a second, but I want to make sure you understand that an object access control list will be evaluated in most cases if there's not an IAM user restriction or a bucket restriction that's an explicit deny. So you need to ensure your permissions are aligned both at the bucket and the object level to ensure your permissions are exactly what you want them to be to limit access as needed for your data. For those that use the S3 console, I'm sure you've noticed this change. So under the access column there, you're seeing an easy way to easily identify whether your buckets are publicly readable. So this is evaluating both bucket policies and bucket access control lists to say, OK, is this content world readable? And it'll label it as public, so you can easily see that in the console. So if that's not the right configuration, if this bucket was improperly changed to that permission level or improperly set up in the first place, it's an easy visual way for you to identify what buckets you should go back and change the permissions on. For the not public bucket, you see the asterisk there, and that's talking about just what we covered on the previous slide, where you'll still want to look at your object access control list to understand the permissions that are being granted for a particular object request. So how do we authorize a request? This is now looking at the prefix level. So when I append that prefix to an object name, I did that for all three of these documents that you see stored here. So they're actually stored within a prefix and can all really be grouped together that way. So I could write policies based on a wildcard after that specific prefix. So this bucket, this prefix, and then all the objects under that, I want to control, and we'll skip ahead to the example. So really, it allows you to write a permission policy for a lot of objects at once rather than using just object ACLs one at a time. So in this user policy example, somebody wanted to grant permission to put, get, and delete objects to a particular user, in this case, Alice. So when you see the object key names that start with example bucket under prefix Alice and any object key after that, we've now authorized permission for this particular user to interact with that subset of storage. So it's an easy way for you to say that amount of storage could really scale up or scale down. It depends on the user and it depends on their needs. But this is an easy way to manage that at the prefix level. So you're not having to give this user bucket level permission, which might be too broad for their needs. But a prefix might be perfect for them. Next example we'll talk about is going back to object tags. So in this case, I want a user to be able to get all the objects that are associated with Project Delta. Project Delta might start very small. It might grow to be a very large project over time, and we'll just continue to tag the data associated with the project. And then if a project ends, let's say this is a consultant or somebody else who's working with our data for a short period of time, when that project ends, you go ahead and delete all those tags or delete the user permission, and now that permission's gone. So it allows you to change that permission over time. You could tag all the data upon ingest that's associated with this project, and this is an easy way to assure that this particular user has access to the data they need. Next, we'll talk about data events in CloudTrail. And when you turn on data events in CloudTrail, it's looking at object-level activity and recording things like gets, puts, and deletes against individual objects in S3. This gives you the visibility at the object level on who's making changes to your storage and who's taking action. Allows you to monitor changes to bucket configurations. And then you can automate alerts from this functionality. So one of the better examples of this is you set up CloudTrail data events, and you say, OK, my object access control lists, I know are exactly the way I want them to be today. If there's ever a change to those access control lists, it's unintended, I don't want them to happen, and I want to revert that change. So you can set up an alarm and an actual automatic action to take place based on these data events, where it will trigger a Lambda function if it sees a change to an object access control list. That Lambda will then revert the change, go back and write back the original object access control list, ensuring that there was no change to the permissions that was unintended. So using data events, CloudWatch events, and Lambda to make that change is a simple loop that you can set up to make sure that changes you don't want to be made to your bucket, you're setting up an alarm and an automatic function to revert those and change them back as needed. And when you set up data events in CloudTrail, you can also use Amazon Macie, which is a new service we launched in August. And this is using machine learning to look at what data you're storing in S3. So it's looking at objects to look for things like personally identifiable information, things like addresses, credit card numbers, social security numbers. This is an indication that there's more sensitive data associated with that particular object. And Amazon Macie is then looking at the permissions associated with that object and giving you alarms and dashboards that are an easy way for you to see, OK, I have sensitive data in S3, and I know I have sensitive data, but are the permissions I'm allowing to those objects aligning with how sensitive that data is? Amazon Macie is a great way to visualize that. It's recognizing the sensitive data. It's monitoring and alarming based on changes that are happening, and also looking for suspicious behavior. So if you see a lot of changes to permissions, for example, maybe a malicious user is accessing your data and is changing the permissions on who's able to access that data, Amazon Macie would see that behavior, alarm on it, and give you the ability to make a change, lock down access to that, remove that particular user. It's going to give you all the visibility to do that. The other one we talked about earlier was the object access control list. And Amazon Macie has a powerful dashboard feature that will show you, based on all the objects you've stored in S3, how many of them are publicly readable at an object ACL level, so an object ACL. It's going to give you an easy way to view that with one of their dashboards that's going to show you, OK, what are all the object permissions I have configured? Easy dashboard seeing what users have permissions, and then also how much of the data is publicly readable. When that's the appropriate configuration, things like websites or content that you're serving worldwide, that's great. If not, Amazon Macie would be a great way to view that and make changes at the object level. The next section we'll talk about data protection. These are additional controls you can put in place to ensure your data is retained and no unintended deletes are occurring. Cross-region replication is the first one we'll touch upon. We'll talk about versioning, and then we'll talk about multi-factor authentication. So cross-region replication allows you to replicate data from any AWS region to any other AWS region. And you configure what the source and destination regions are. So I could take data that's uploaded in Mumbai and move it to Northern Virginia. I could point that the other way as well, saying that all the data uploaded to Northern Virginia should also be copied over to Mumbai. I have all the flexibility here as we launch new AWS regions to change my replication, getting it either closer to my users or just achieving the geographic separation I want to achieve for compliance purposes. So you can replicate, you can configure that at the bucket or prefix level, and then you could also trigger replication on individual objects as needed. Two of the recent enhancements for this, also launched early in the month of November, is now we support KMS encrypted objects. So if you're using data and encrypting it with a key management service, you can now replicate that data, which is still encrypted, across to your destination region and be able to access it there as well. So you can use KMS encrypted data and use replication now. The other one is ownership overwrite. And this allows you to do cross-account replication, which you were already able to do, but now change the object access control list. So the object ACL as the replication is happening. So now I ensure that the proper permissions are there in the destination bucket. So if I want to maintain different ownership stacks of this object in my source and destination region, allowing ownership overwrite ensures that the bucket owner in the destination can read the object and access the object as needed. So it allows you to set up different ownership stacks, which can be an additional level of data protection. Versioning protects your data from accidental deletion. And it does this by creating new versions of your object every time you overwrite a particular object key. So every time you upload an object with the same key, we're going to maintain a new version of it. And you see that visually on the right, where I've uploaded the same image multiple times, and now I'm maintaining 5 versions, 3 versions, 1 version as necessary. So as those additional writes come in, we're maintaining all of them, so you can actually go back and using the get on the object key name and the particular version, you can go back and get any of those particular objects you need. So it tracks the changes over time. It also protects against unintended deletes. Because if I issue a delete command against an object in a version bucket, we're placing a delete marker on top of that object, which means that if you go back and get it, you'll error as if the object doesn't exist. But an administrator or anyone else with the proper permission could go back, remove the delete marker, and actually get access to the data. So when a delete's issued against a version bucket and a particular object, we're still retaining the data. We're just removing access for people to go ahead and get that data. So that allows you to configure, roll back those deletes, and get the data that you need. You're also allowed to configure lifecycle policies, which we mentioned earlier, based on whether something is the current or previous version. So if you're worried about building up multiple versions of a particular object and building up the storage over time, you can configure a lifecycle policy saying after a certain period of time, go ahead and delete the old versions of the object. So it's easy to set up a policy that'll help you control the amount of data that's being retained when you set up versioning. Multi-factor authentication is another way to control deletes on your object. So it adds another layer of protection by requiring not only an authorized request against S3 to delete an object, but also requiring a unique code from a token or an authentication device. So this can be a virtual device or it can be a hardware device as you see a token up on the screen, which is going to have a unique code that you'll have to submit to S3 to actually go ahead and delete an object. So if you really need to retain your data in S3, want to ensure it's not deleted, this is a setting you can set, requires that multi-factor authentication. No user without that code is going to be able to delete objects within your bucket. So you can lock down access to that code to whatever users aligns with your needs. Next, we'll talk about achieving high levels of performance on S3. So the first one we'll touch upon is best practices around object key naming. Then we'll talk about S3 transfer acceleration, and then a few other best practices you can use, including using a content delivery network like Amazon CloudFront. The first thing I want to highlight here is to achieve high levels of performance on S3 happens by default. If you're going to achieve higher than about 1,000 requests per second, this particular best practice where you add hashes to the beginning of your key name is something you should consider. So if you anticipate growing to above that level, this is a combination of puts and gets in your object, over about 1,000 requests, you want to look at this best practice. So if you think you might grow to that over time, it's easy to implement these changes today or implement these today on your bucket and ensure you're going to scale with no issues on S3. If you're going to be below that level and you don't see a lot of traffic on your storage, don't worry about this at all. We automatically partition your data over time as your request pattern grows, and that's something that you really never have to worry about if you have a lower amount of requests. I want to go into detail, though, on how you can add that hash. And this is important because object keys are stored in an index in all AWS regions. And if you're constantly writing the same object key over and over again, like let's say it starts with a date and it starts with a year, so you just keep writing the same bucket in 2017 over and over again for each new put, that's going to place all your objects pretty much next to each other or very close to each other within the same partition in the index. That means if your traffic really scales up readily, it's going to be trying to do all those reads from the same section of the index, and that's where you may experience some performance slowdowns as we try to spread out your data and allow you to achieve those higher levels of throughput that you're trying to achieve. By putting the hash at the beginning of your key name, you're then adding randomness. So you could hash the key name, place it at the beginning of your object right after the bucket name, and now you have randomness inserted at the beginning of your object key name very early on, ensuring that your data is going to be spread across different partitions and allowing you to grow to a higher level of throughput without experiencing any slowdown along the way. The second example you see down below is, let's say I'm storing a lot of animations, videos, and photos in S3. If a lot of my traffic is going to fall under those headers, and I know I'm going to store my storage that way, I can add the prefix ahead of the hash, knowing that I'm going to have a lot of traffic to those individual prefixes. And that allows me to do things like write prefixes into my lifecycle policies, or also do list API calls against a particular prefix using animations, videos, or photos. I'm still getting the performance benefit by adding the hash to my key name, but now I can also use a prefix as necessary. So it's a way you can balance the needs to list your objects and organize them against the need to spread out your data across different partitions. One of the features I mentioned that I touched on earlier is S3 transfer acceleration. The real benefit you're going to see here is for larger objects across larger geographic distances. So instead of using the public internet, in this case from somewhere in Southeast Asia and uploading data all the way to Northern Virginia, you're now taking advantage of S3's content delivery network, where we have edge locations around the world. You're uploading your data to the closest edge location, and then you're traveling across the AWS backbone to your destination region. So you're no longer experiencing any issues or slowdowns you might associate with just traveling across the public internet. You're now on the AWS backbone, which can lead to a significant performance improvement. And importantly, when you look at this, you're specifying this in the request. There's really no application changes. It's just something you're specifying in the request. I want to use transfer acceleration, or I do not. You can continue to admit that. But if you want to achieve higher levels of performance, this might be a great fit. And if it doesn't achieve faster performance, and your upload isn't going to be faster than it would have been normally over the internet, there's no additional charge for using transfer acceleration. So there's a small fee for using it if it improves your performance. If it doesn't improve your performance, there's no charge for using transfer acceleration. And this is an example showing, so this is uploading to a bucket in Singapore from different edge locations around the world. And you see that typically transfer acceleration is being uploaded in this particular example in about half the time. This is a 500 gigabyte object, so it's a fairly large object. And you're seeing that you get significant savings in time for this upload by using transfer acceleration. So where that's important to you and where that's important to your end users to get data up to the cloud quickly for analysis or to kick off another process, transfer acceleration could be a great fit. Three of the other ones I want to touch upon briefly is using a CDN like CloudFront, where you'll get lower latency, potentially higher throughput performance, and you won't experience as many requests to S3. So if you have objects that are being read very frequently, it'll cache those at the edge, and then users will experience the performance improvement of having cache storage through a CDN versus going back to Amazon S3 for each new get on that object. So if you're seeing a lot of traffic, CloudFront could improve your performance there. For multi-part uploads, instead of uploading an object all at once, whether it's gigabyte scale, terabyte scale, up to 5 terabytes, you can upload an object to S3. Uploading that all at once as a single-threaded process can take a long time, as I'm sure some of you have experienced. Using multi-part uploads, you break that object into smaller parts, you can parallelize the uploads, then you submit a manifest file telling us, OK, all of that multi-part upload, now assemble all of those individual pieces to a single S3 object. So I still want to store it as one object, but allows me to parallelize and then also improve the performance, get back successful requests more frequently, because I'm doing a smaller upload for the multi-part upload as you upload those smaller chunks. The other one is range gets. So it's a similar idea, but in reverse. So I'm downloading potentially a large object. If I'm tracking the offsets, I could use range gets to say, OK, I want to download this object not as one full object, but I want to download 10 parts of it. So you could use range gets to specify the individual parts of an object you want to download. Now I'm downloading them all in parallel and potentially seeing a performance improvement there as well. And now I will bring up Katie Lampkin. She's a software engineer for Human Longevity. She's leading the effort to control access to their Amazon S3 storage. She has extensive experience in serverless technologies integrating with Amazon S3, and also experience with managing billions of objects at a multi-petabyte scale. So bring up Katie.
Hi, as Rob stated, I'm Katie Lampkin, and I'm a software engineer at Human Longevity. So just to give you guys a little bit of background about Human Longevity, it's a human genomics company founded by Craig Venter, and it was founded in 2013. Its headquarters is in San Diego, and we're making an impact by gathering quality genomic data as well as phenotypic data. We perform a whole genome sequencing in order to make discoveries based off the entirety of the genome rather than just a portion of it in conjunction with phenotypic data. So the goal of Human Longevity is not only to make life longer, but make life worth living. We reach this goal by attempting to build a large database of the quality genotypic data and phenotypic data and performing analysis on this data using machine learning technologies and deep learning techniques. We are bringing preventative healthcare to the market instead of using reactive healthcare through providing a new level of health intelligence. So here's a little bit about our flow of data through HLI. The most streamlined way that we receive our data is through our clinical research facility called Health Nucleus. Within the Health Nucleus, people can come in and we will sequence their genome as well as gather different types of phenotype data. So some examples of that phenotype data can be a full body MRI and brain MRI, CT scans, blood labs, other types of tests, and gathering information like height, weight, other information about their medical history, etc. Then from there, we sequence their genome and analyze their data, and then the result is we give them back a report that is their health intelligence. So we can give them information like, hey, you might have these risks for cancers based off your genome, or these neurological risks. But we can also give them some fun information like their ancestry, or whether they turn red when they drink alcohol. So a little bit about our sequencing lab. We have about 32 sequencers, and we sequence both human genomes and microbiome genomes. So for those that don't know, the microbiome refers to the bacteria in the gut. So we will sequence the bacteria in your gut to get a little bit more information about how that works out too. Right now, our database consists of a little over 40,000 whole human genomes, as well as 3,000 microbiome genomes. And in conjunction with the 40,000 whole genomes, we also have phenotype data to go along with it. Now that adds up to about 6 petabytes of data in S3 and 10 petabytes of data in Glacier. So where does this data come from? We put the samples into our sequencer, and after the sequencer is done sequencing, it dumps the data into our local Isilon storage, and then Aspera uploads that data into S3. Now those files can be about 400,000 what we call BCL files, and those get tarred into a file that's about 600 gigabytes. Now when that file gets dropped into S3, it triggers our primary analysis platform that takes those files and turns it into a raw genome file, which is about 200 gigabytes. From there, after primary analysis is done, a Lambda gets triggered and checks, okay, once this workflow has finished, what is the next workflow I need to run? After primary analysis comes secondary analysis, and so on and so forth. So after every workflow completes, we want to make sure that we run all of our tools against our set, and we do that through the Lambda triggers. And after every workflow completes, all of that data gets dumped into S3. So while this analysis is happening in the cloud, we have professionals analyze the phenotype data and map it and standardize it to specific ontologies. And then that data, once standardized, gets uploaded into S3 as well. So S3 is kind of our merging ground for our genotypic data and our phenotypic data. So we have 4 main business needs when it comes to securing our data. The default case is the patient or partner allows us access to the data, so there are no restrictions on that data. Now, the 3 edge cases are a patient or partner will deny complete access to that data, so no one ever should have access to that data. The second one is a patient or partner only allows our specific research team to have access to that data, which means no one else can have access but that select group. And the third and final one is a partner allows HLI ownership of that data after an allotted period of time. So let's say it's after a year of sequencing. So a year after that sequencing date, that data belongs to HLI and we can have access to it. But during that year period, we are not allowed to have access to it, so it is restricted. Now, how do we control those business needs in a technological way? We used Amazon S3 tags as well as IAM managed policies. So the 3 tags that we decided to use were rights, restrictions, and project ID. So let's go through those. Rights. Do we have rights to that data now, or will we ever have rights to that data in the future? If we do, we will mark it as true, the value. If we do not, then the value will be false. Restriction. Is there currently a restriction on that piece of data? If there is, the value is true. If there's no restriction, the value is false. Now, project ID. If this data relates back to a specific project, then we mark it with the project ID. This relates back to the edge business case where if a partner or patient only wants our research team to have access to that data, we can keep track of it using this project ID and allow only specific users to have access to it based off that project ID. So, as I said, we have petabytes of data in S3, and that adds up to hundreds of millions of files. So if we wanted to tag all these files, we had to come up with a solution that could tag them and tag them efficiently and quickly. So we did that using a serverless solution. So once a workflow completes and has uploaded its files into S3, an SNS message gets sent off. And that triggers a step function that has a series of controlled lambdas, controlled parallelized lambdas that go out and tag all the files. Now, each of these individual lambdas that go out and tag the files, they hit our own API, gather the list of files they need to tag, as well as the tags that they need to tag them with, and then go out and tag all the files in S3. If we were to only do this with one lambda, it would be extremely slow and it wouldn't have the efficiency that we want it to. If we were to trigger lambda thousands of times and have the parallelization expand out as lambda does, it would cause throttling on our APIs as well as the S3 API. So step functions was a really good way to control that parallelization, to have the optimized speed, but not throttle any of the services. So let's talk a little bit about the IAM managed policies. So we had 2 different types of policies. We have implicit allow and implicit deny. Now, implicit allow, when we map that to a bucket, says the default case is allow. So any file in that bucket that does not have the respective tags is open access to everyone. But if we have a specific tag that matches to a specific value, then that file will be restricted. Now, implicit deny is the opposite. The implicit deny policy, when we map it to that bucket, everything in that bucket will be restricted. Now, if it has a specific key value pair for the tags, then that is when it is allowed to have access. So here's an example of our implicit allow policy. We're controlling get object and get object version because we not only want to restrict access to just getting access to the object, but all of its versions as well. Now here are the 2 conditions that really matter. So when rights is false and restriction is true, that means that we should not have access to that data. So we say, okay, if those values are there, then we're restricting access. Otherwise, it's open. The second condition leaves it available for having a project ID in there. And in this case, the project ID is PJ-1234. So later on, we can take roles and map it to that particular tag and say, hey, even if this is restricted, if there's this project ID tag, allow this role to have access to this object. Now here's an example of implicit deny policy. So the implicit deny policy, we actually broke it down into 2 separate statements to show not only can you do it in one statement, but you can do it in 2 statements and separate the conditions. So again, we're controlling access to the object and all of its versions. And then we're saying, hey, if rights is true and restrictions is false, then we have access to this data. So we allow access on that. And then we have our second condition in our second statement that says, hey, if we have a project ID and we need to allow our specific groups to have access to it, we can use that project ID tag to have access. So HLI has done a lot with our data, and I think one of the most impressive things, in my opinion, being a software engineer, is what we call our open search tool. So we take all of this data that we're allowed to have access to, and we upload it into this tool that we can do queries on both the phenotypic data and the genotypic data. So we can do queries based off of demographics or age or a specific variant in your genome and gather information, build these graphs so that our scientists and researchers can analyze that data and make conclusions from it. Another one that's kind of interesting is that we produced a paper that said that we can have machine learning technologies to kind of analyze physical traits of people. So when we sequence the human genome, we can go through and say, hey, based off of these parts of your genome, this is kind of what your face is going to look like. And I thought that was really interesting to me. We've done a lot with AWS and Amazon S3, and I really look forward to everything that we're going to do with it in the future.
Thank you very much, Katie. This is only the beginning of a great week of storage presentations, so you have options on Tuesday, Wednesday, and Thursday. Go ahead and mark any of those down. And I'll flip back to this slide in a second. I would love to thank all of you for joining us today. Keep an eye out for those with the pins on with the S3 logo, and that will help you do get additional questions answered. I'll go back to this slide, and we do have a few minutes for Q&A, so for anyone who wants to come up to the microphone and ask any questions now, we can take those for myself and Katie.